Hello, my name is Shin here. I'm explaining the method of dealing with variance, published in Japan. This time, I'll explain the various judgment indices of calculation results that become possible by using the method of dealing with variance. The method of dealing with variance makes it possible to calculate the distribution of the necessary parameters using distribution calculations. And by correctly determining the shape of that distribution, advanced design becomes possible using various judgment indices. This time, I've summarized those judgment indices. In the latest publicly available tool, you can use the 4 judgment indices described here. By using the distribution calculations and distribution integrals explained in the book and video, you can obtain the correct shape of the distribution of the calculation results, which makes it possible to use these judgment indices, enabling highly accurate judgments that take variance into account in design and analysis. The top 2 functions have been built into the tool from the beginning. The bottom 2 are new functions that have been added recently. Percentile is a well-known method that divides a distribution at a specified boundary and gives the probability of exceeding or falling below the boundary value. In the publicly available tool, you can calculate the probability of this percentile in an area where a 2-dimensional or 3-dimensional distribution is divided by any number of surfaces. Distribution comparison extends the percentile boundary to the distribution and shows the positional relationship between the 2 distributions probabilistically. Comparing 2 distributions is expected to improve the design accuracy in various design decisions. For example, the book explains how determining the probability that the parameters of one distribution exceed the parameters of another distribution can improve the accuracy of many designs, such as software design that handles random events, hardware life calculations, and system performance predictions. In the book, distribution approach is explained as the probability that the parameters of 2 distributions match. Since the probability of a perfect match changes depending on the division of the parameters, a certain distance is given and the probability that the other exists closer than that distance is given. In other words, it gives the probability that the distance between the parameter values of 2 probability distributions is within a certain range. This makes it possible to calculate the probability of hitting a target or obstacle. Distribution balance is a newly added function that gives the parameter values and cumulative values of the point where the 2 distributions, cumulated in the negative and positive directions, intersect. This is a graph that gives the point where demand and supply are balanced, which is often used in economics, and searches for the point where the cumulation of 2 opposing distributions is balanced. The above judgment indices have traditionally been discussed in terms of images, but by using them in combination with distribution calculations, they can be used as part of a rigorous model. Below, I will explain each of the judgment indices in more detail. First, let me explain what percentiles can do. A recently released tool has a function to calculate percentiles when a distribution up to 3 dimensions is divided at any boundary. These are all graphs created with the published tools. GitHub has repositories called Bungpo2 and Bungpo3, which contain a sample script file called script2.py. These graphs can be created by writing the Bungpo_% or Bungpo_%3 functions using this as a reference. This makes it possible to find the probability of achieving a goal or the probability of contact with an obstacle from the results of distribution calculations or simulation results using distribution integrals. However, it is common for the position of the goal line and obstacles to also have variance, and in such cases it is more accurate to use a distribution comparison that treats the threshold or boundary surface as a distribution. For example, when comparing distributions. When comparing a distribution with a mean value of 129. When comparing a distribution with a mean value of 305. When the distribution with 305 is considered a cumulative distribution, the area of the distribution of the product of the 2 probability values gives a probability of 2.42% that the distribution with 129 exceeds the distribution with 305. The probability value is displayed in the graph as an overlap ratio or percentage. In this case, the distribution of the product sticks to 0 and cannot be seen. But a graph is also generated in which the probability value is displayed logarithmically as shown here, so the stuck part can be seen. In the book, this comparison of distributions is used to provide a detailed explanation of the calculation methods for hardware life design, software design for random event processing, and system design for autonomous vehicle control, so please refer to it. The book also explains the comparison of 2-dimensional and 3-dimensional distributions as shown in right graphs. Use this comparison of distributions to think of various new applications in your field of expertise. The approach of distributions gives the probability that the parameters of two distributions will come within a specified distance. This is done by overlaying all the probability values of one probability distribution, shifted by small intervals over a specified distance range, to create a distribution that is the product of this probability value and another probability distribution, and the area of this distribution is the probability of approach. This can also be calculated for 2D and 3D distributions, and can be used to calculate, for example, the probability of a shell or missile shooting down a target. In the tool's sample script, it can be generated using the function called bungpo_twin_graph and the file called script2. The balance of the distribution is a redefinition of the supply and demand curve used in microeconomics using a probability distribution. A commonly used supply and demand curve has the price of an item on the vertical axis and the number of items on the horizontal axis, but in this diagram the vertical and horizontal axes are reversed. This is because this supply and demand curve combines a cumulative distribution in which the cumulative distribution of the number of items purchased, with the purchase price of demand as a parameter, is cumulated in the negative direction. A cumulative distribution in which the cumulative distribution of the number of items sold, with the selling price of supply as a parameter, is cumulated in the positive direction, into a single graph. And the intersection point is found to be the point where the price is balanced, where the number of items purchased and the number of items sold are equal. For example, this demand distribution can be found by multiplying the frequency distribution of national income by 1 minus the tax burden rate, which gives disposable income, which can be found by multiplying it by the distribution of the purchase decision ratio. The purchase decision ratio is a probability distribution that shows what percentage of people will purchase an item when the price is about what percentage of disposable income, and is provisionally set to an appropriate distribution. The supply distribution can be found from the distribution of production costs, labor costs, etc., but here I will assume that the distribution is upward sloping to the right. In reality, it may be downward sloping. The cumulative distribution obtained by cumulating this demand distribution and supply distribution in the negative and positive directions respectively is the distribution that gives the supply and demand balance. In the tool, this can be found using the bungpo_balance function in the bungpo2 sample script. This is a comparison table of software that realizes the environment for the published method of dealing with variance. You can download it from the repository address. Currently, 3 software programs are published, and the software in the repository called bungpo is the one explained in the book. It executes functions by specifying them from a pull-down menu, and is intended for beginners. The 2 on the right were created after the book, and both read and execute scripts that describe functions. Of these, bungpo2 is a Windows executable format, and a small screen will appear. Click Select File to load a script, and execute the script with Execute. bungpo3 functions as a Python library, and by importing the library called bungpo, you can use distribution calculation functions in Python. Both have sample scripts, and we have explained how to use them in past Japanese videos. If you are just using the downloaded software for feasibility study purposes and not for commercial, it is free, so please try it. The functions for using the judgment indices explained earlier will be compiled in bungpo_function.pdf in the bungpo3 repository, where we will provide a list of functions like those written here. This is still under construction, but I will update it in the future, so please wait. This is the end of the video. Thank you very much.